Going to take a look at a graphical approach to describing functions. This is a skill learned in pre-calculus, and we're preparing for doing an analytical approach to describing the behavior of a function. So in this video, I'm just going to review some of the terms used to describe a graph, and beginning with increasing region. So recall that that is a domain interval where the function is rising to the right. By the way, so when we state, when somebody asks us to describe where a function is increasing or decreasing, we have to answer in a certain way. So it is most common to state for these types of regions, we're stating a domain interval. All right, so increasing regions is where the function's rising to the right. As x's increase, the y's are increasing. Decreasing regions are regions where the graph is falling to the right. As x's increase, the y values are decreasing. Okay. All right, so let's look at our next. We have extrema for a function. There's two types, local and global. Local, there's another term used for that. It's called relative. So you'll see those terms used interchangeably. And these are local minima or maxima in a given domain. So we take a small portion of a domain, not the entire domain necessarily, just a small portion, and we look for peaks and valleys, possibly even endpoints. So the high and low points of a graph within a local region. A global extrema is the absolute highest y value or absolute lowest y value on the entire domain. So typically you would have probably no more than one absolute maximum or absolute minimum, though they can repeat, as you can have more than one if they are equal y values. Okay, so that can occur, like the sine graph. The sine of pi over 2 is 1. The sine of 5 pi over 2 is 1. So, so you can have that happen on multiple locations. And so when you state the answer, there are three ways to do it. So one way to state the answer is to state the y value. This is asking you for the highest and lowest point, so it's very common to just state the y value where that occurs. Okay, another way to state it is as an ordered pair. So you could state the location of the highest or lowest y value using the coordinate, the x, to help locate it. Another way to state it is like in a sentence form. So you might say, for instance, I'll put it in quotes just to say as an example. So the absolute, let me abbreviate that for space. So the absolute max, for instance, of, and then you state a y value, and then at x equals, and then you state an x value. Got so many quotes going on here, right? Okay, so something like that. Absolute max of 4 at x equals 2, something like that. All right, so you would state a sentence to describe that absolute or global extrema. All right, so these are locations. Concavity. Concavity is a way to describe the curvature of a graph. So we can see that these are concave up curves. We split it into two because you could have a region that is concave up and decreasing only. It could look like that, or a concave up and increasing, or they could be connected. And then concave down is like a bowl down description. So concave down and decreasing versus concave down and increasing. And we can connect these pieces in multiple ways, right? So we could say we could do concave up, and then it could switch to concave down. So you could get that switching. Or you could have concave, you could do something like concave up, and then have concave down like this and be kind of pointy. but we can connect these curves in multiple ways. By the way, so when you state the region, you are stating a domain interval where these occur. Oops, forgot my T. And I can't spell, right? So domain interval. Let me fix that. Domain interval. All right. So the last part related to concavity is inflection points. Inflection point is a location x comma y where the function changes concavity. So when you state an inflection point, you do list an ordered pair. All right, so what is an inflection point? It's where you change, and you actually have to have a change in concavity. So if you have a graph that does this, all right, so here's a point right here. It's concave, this is concave up and decreasing, and concave up and decreasing and increasing, but we didn't have a change in concavity. So this is not an inflection point, and I'll abbreviate that IP. Okay, you have to show change. All right, so what would be a change? I could have concave up and decreasing and then go to concave down and decreasing. This is an inflection point. And of course, we can connect these in different ways to come up with different pictures. So the concavity has to actually change, right? Okay, so that's a basic review of all the terminologies. It's time for some examples in the next video.